This is a crab shell, and within it lies a fibrous called chitin. Chitin normally bind together with a protein, and both of them are embedded within the hard matrix of mineral. We call it calcium carbonate. That's why when we do like this, it feels hard. That is calcium carbonate. The function of chitin is to give structural integrity to the crab shell, much like our bone give structure and support to our body. Being a structural material allow us to extract this natural polymer within the crab shell, the chitin itself, and use it in many applications. For example, in packaging, food technology, membrane, advanced material, or even biomedical application. In this video, we will show you step-by-step process of extraction chitin from 200 gram of crab shell. So this is 200 gram of crab shell, this much. Okay. But before we show the practice, let's get a little bit about theory. There are 4 steps to extract chitin from crab shell. The first one is acid demineralization. The second one is hot water extraction. The third one is alkali deproteinization, and the last one is neutralization. Sometimes people combine the hot water and the alkali deproteinization together. But in our purpose, we separate into 2 so that it can be our chitin is much more cleaner lah. So the first one, the acid demineralization. The purpose of it is to remove, to dissolve the hard mineral, the calcium carbonate within this shell. So we use the parameter 1 molar of hydrochloric acid and do the step for 30 minutes. And then we subject it to hot water extraction. The purpose is to remove all the soluble material. So that is conducted in 85 degrees Celsius for 1 hour, and then we subject to the alkali deproteinization. So we use 1 molar sodium hydroxide, and we conduct the step for about 3 hours at 65 degrees Celsius, and lastly we will just wash it using water until it becomes neutral. So it's fairly straightforward process. And during this process, we use 1 to 40 solid to solution ratio. For example, we start with the we start with the acid demineralization. So to determine the working volume of that acid, we multiply the dry weight of this crab shell to the 40. So that's 140. So because crab shell doesn't have water, it's dry, so we assume this just dry lah. So if we have 200 gram of crab shell, we multiply it with the 140, the ratio that we mentioned before. So we got around 800 grams. So that's equivalent to 8 liters of solution. So for our start acid demineralization, we will use 8 liters acid, 1 molar acid to conduct the acid demineralization step lah. And then after that, we will continue with the hot water extract. So we continue with the 8 liters of water, and then after that we continue with 8 liters of alkali during the deproteinization step, and then we wash it until the thing becomes neutral. So it's quite simple, but let's see the practice. At the end of the day, at the end of this video, we will share to you about how much chitin that we obtain from this 200 gram of crab shell. But for now, let's see the method itself. Okay, so here we got a container, 80-liter container of crab shell. So this crab shell, we collect it from a morning market. In Malaysia, typically there are a lot of sellers selling crabs around October, end of the year like that. And you can go to them and ask them to separate the crab shell for you. So in Malaysia, typically there are 2 types of crabs that sold, which is this type. This is blue swimmer crab, or in Malay we call it ketam bunga. Normally at the beginning, before we dry, this shell is blue in color. That's why they got the name lah, blue swimmer crab. But then when you dry it under the sun or you heat it, they turn into orange. And another type of crab that you typically found in Malaysia is this type. This is coral swimmer crab, or in Malay we call it ketam karang. Okay, so this also type that you can find normally in Malaysia lah. So we have this 80 liters of worth of crab shell. So let's see how much each of the shell roughly weight. Okay, so this crab shell weight about 7.5 gram. Let's see the smaller one. So this are about 5 gram, and maybe we wait another one. So this is around 7. So we can say our crab shell here, the weight for each one is roughly around 5 to 8 gram. So let's see how much this total container weighs, so that we can estimate how much crab shell that we have here. We already tear this container into on this scale. So let's see. Okay, so it's about 3 kilogram. Okay, so 3 kilogram worth of crab shell here. So if one of it is around 5 to 8 gram, so we have about 350 to 450 crab shell in this container. So now what we want to do, we want to crush this crab shell into powder. So we need to have a few things ready. So we have this what we call a plastic bag. Whatever plastic bag is sufficient. The purpose of this plastic bag is to put our crab shell inside that, and then we try to what I call crush it using this mallet. Okay, before we grind it using this grinder. So we have grinder here, and also after we grind, we will sieve our crab shell using this what I call sieve. We use what is the size here? So we use 250 micron opening for sieving, or roughly 60 mesh lah. Okay, and also we have what we call a beaker at the bottom here, just to collect our sieve product bottom. And also we ready with our container. After we sieve, we put everything inside this container, and we also have our paper pen here in order to note down any weight or whatever. And we have also this funnel to make us easy to put our sieve material inside our container. So roughly that is basically the accessories that we need in order to process this crab shell from shell to the powder. Okay, first we put our crab shell into this plastic bag in order to get the weight. For our chitin extraction later on, we want to use only 200 gram. So we will weigh about 500 gram worth of crab shell for grinding purpose, and the rest we will crush it later on. Okay, so this is how much 500 gram looks like. Okay, of crab shell. So how much of this? Maybe around like because if of the crab shell is around, let's say 8 gram, so 500, so you get around 60 or 70 crab shell here. So now we will crush this thing in order for us to what I call to put into this grinder. Okay, I think that's enough. So let's put it into our grinder. So this is a high-speed grinder, dry grinder. So it's used to grind herbs or something like that. This grinder have the capacity about 2.5 liters volume. It's important for you when you want to use this grinder is to make your sample to fill up this grinder at least 80% of the volume, because if you put very less, then the sample will not be grinded efficiently because it will be too small, and then the sample will be beneath the blade. So you need to make sure all your dry sample cover your the volume lah. Can you put more? Remember, this grinder have also the lid, and the lid, you see there are some extra space there, so it's okay for you to put like this. I mean more than is what I call is surface here, because you will offset with this space on the lid itself. And although we see that's like a full, but after grinding you will see that the powder is just, or maybe only this height only. Okay, so 500 gram is good enough. I mean, it will fill up this grinder nicely. Make sure when you want to use this dry grinder, your sample is very dry. We don't want any moisture, any water, because this grinder is meant only for dry sample. And if you look at the spec for this grinder, if you look here at the bottom here, it said that the maximum speed, the motor speed, is about 32,000 rotation per minute, and then the degree of grinding here is about 50 to 300 mesh. 50 is about 200 micron size. Okay. Operating time 5 minutes, meaning that the maximum time you can use this continuously is 5 minutes, or else it becomes so hot. But for safe practice, we only do the grinding for 1 minute, and then we let it cool for a while, and then if the sample is not fully grind yet, we will repeat again another 1 minute, and then we let it settle down, I mean in terms of cooling down, and then we repeat it again. It's very important because this grinder will generate a lot of heat. So by allowing to settle down, cooling down, you not only preserve this grinder motor, but also you prevent your sample from overheating, in case your sample very sensitive to that. Okay, so now we will close it. So here you don't need to do like too tight, because this thing you can put like this, like that. Okay. Because if you put too tight, then later on when you grind, it become heat up, and it's very difficult for you to open this. So just what I call close it in such a way that it's not too tight, just enough for you to, because remember when it's heating, it's expand, and then it will make you, it's so difficult for you to open it later on. Okay, and then we open our and then this is like the timer for the grinder. Okay, so they don't have I mean, it's better for you to use your own clock to set like 1 minute maximum, and then we stop. Okay, so typically we will be very careful when using the high speed blender like this. So make sure everything is closed nicely before you even attempt to on this thing. Okay, let's start. Okay, so already 1 minute, so let's open to see how much grinding have been done. And you can feel that it's very hot now, even though we just grind for 1 minute. This high speed grinder behave like that. And you want to open this, we need to open it slowly, because why? Because if the thing is very fine, then there will be sort of like dust coming out. So you can see, this is what I said, dust particle from the sample itself. So normally when you see something like this coming out, you can say that almost surely that your samples already grind properly lah. Okay, so from the full of shell previously, now after grinding, you see how much it goes down. So that's the reason why at the beginning you need to fill up this to the max volume, because you don't know when it become particle like this, the volume become smaller and smaller. Okay, so now what we do, we will sieve this thing. Here we use a container that is nicely fit with our sieve, so that we can sort of like what you call shake this thing. Okay, you can also use this brush in order to fasten up the sieving process. You can see at the bottom here, while you do that, the sample will go through the opening much faster. On the lid also, there are some fine particle that is stuck during the grinding. So you can use this also, the wooden the brush, in order to take it out and put on this sieve. Okay, we already sieve it for a while, and as you can see, for now we got this much of sample, so we believe this is enough for our next extraction before. So for the sample that's not yet being sieved, what we can do is that we can save it into this what I call unsieved sample, so that later on when we try to grind, we can grind this together. Okay, so for this what we call sieve sample, the size is about 300 micron and below, 250 micron and below. So we will store this into separate container. So at the beginning we want to put in the big container there, but we found that this is quite not much, so we can, I think, sufficient to put in the small beaker. So for next extraction, chitin extraction, we only need 200 gram. So let's wait first how much is this, whether it is below or above what we need. Okay, first we will weight our empty container, so that is 80 gram, and then we tear our container, then we add our sample. We got around 322 gram, so which is enough for us. We only need 200 gram for our chitin extraction later on. So this is enough for us. So next time when we want to extract further chitin, we will crush, grind and sieve again. Okay, for the sieve itself, we need to clean it before we store it. Because this sieve have a very small opening, 250 micron only, so it's quite difficult to remove all the small small sample there that is stuck there. But we cannot force this thing to coming out, because we're afraid that the sieve will be tear up lah. So it's advisable if you have a specific sieve for specific sample. For example, here, if we use this for crab shell sieving, and then we just only use this for crab shell, okay, that's much more easy lah, because it will not contaminate with other sample. So we will try to brush it as much as possible, and also of course we can rinse it with the water, but we believe that even if you do that, then the small sample that is stuck in between the pore here cannot be removed. So better we just maintain the sieve for the crab shell only. So before we store, make sure you label your container. So this crab shell around 300 gram, the date and also the size itself is around 250 micron and below. So let's see the texture of it. So this is how the texture of 300 or 250 micron of crab shell, crushed crab shell. So this is what we will use for our chitin extraction later on. The reason why we crush it, sieve it, is because to make sure
our batch have some standard. From batch to batch, we can maintain our extraction process, and also the sieve. So at least it's repeatable from batch to batch, our extraction process. So now we continue with the extraction part.
To extract chitin from crab shell, we need to prepare all our material in advance in order to make our life easier later on. So obviously we need a crab shell in order to extract chitin from the crab. So here we only need 200 grams of crab shell, and this crab shell, our samples already sieve, already grind and sieve under 250 micron size. So we will use 1:40 ratio solid to liquid ratio during our extraction process. Our extraction process for crab shell involves 3 steps. The first one is acid demineralization, and the second one is hot water extraction, and the third one is alkali deproteinization. All 3 steps here we will use the ratio of 1:40, meaning that 1 part of solid to 40 part of liquid. So if we use 200 gram here, so 200 times 40, so it will equivalent to 8 liters of volume. So all our extraction will be use 8 liters volume during the process. And here is some of the consumable. Obviously we need this PPE, the glove, because we will handling the alkali and also the acid. We also have here the petri dish, glass petri dish for dry weight calculation. We have the spatula here. We also have this marker pen for labeling. We also prepare the distilled water in the wash bottle and also in the spray form to spray, to rinse our sample later on. And we also prepare the ethanol, 70% ethanol. And here, because we will use acid demineralization, we need the acid. So we use acid hydrochloric in our purpose. So this acid HCl is typically come in 37% concentration. So it's fuming, meaning that you need to work this in the fume hood when you want to use this. When you want to pour this to dilute it, then you need to put it in the fume hood. And also this acid has the molarity of 36.46 gram per mole. And when you calculate the volume and also the density here, the density for this acid is around 1.2 gram per ml. So you will find that this entire acid, this entire bottle, stock bottle here, contain 12 molar of acid. So we will only use 1 molar acid, meaning that we will dilute this. Okay, so as we mentioned before, the ratio that we use is 1:40, and the total working volume is 8 liter. So in order to make 1 liter, 8 liter of 1 molar hydrochloric acid, we need to dilute 657 ml of this to the water. Okay. So that's one thing. So you need to make sure you have enough acid to begin with. And also we will sort of use the sodium hydroxide as our alkali deproteinization chemical. So sodium hydroxide has has the molarity is about 40 gram per mole, meaning that if you want to make 1 liter, you need to add 40 gram of pellet inside this. But our working volume is 8 liter, so 40 times 8, it will be equivalent to 320 gram of pellet to be used. So we need to make sure we have enough sodium hydroxide before we start. Okay, 320 gram for 8 liters, 1 molar sodium hydroxide. So we use this this graduated cylinder in order to measure our acid for dilution later on. And normally the correct way, the most accurate way to dilute the acid is to use this the volumetric flask. So you add some water inside, and then you add acid, and then you you top up the water until it reach this mark. Okay, until it reach this mark. So that is more accurate way lah to make any molarity of acid or base lah. But for our purpose, we just use this and we just use a graduated cylinder is more than enough, because it's not too critical to our work. Unless you work with the molecular thing, or you really need very accurate 1 molar concentration, then yes, you need to use the volumetric flask. But for our purpose, just for extraction, plus minus is okay, so we use this graduated cylinder for our purpose. And we don't use blender for this chitin extraction from the crab, but the reason why we have blender here is just because as a measuring cup, because here this blender have the max capacity of 2 liters here, 2 liters, and also is graduated, so it's easy for us to know how much that we use lah. And because we use 8 liters volume for 3 type of extraction, the hot water, the acid demineralization, and the alkali deprotonization, so 8 times 8 is already 24 liters. So here we need to prepare in advance the distilled water. So here 1 bottle here is around 10 liters, so we have 40 liters of distilled water. It's more than enough lah, because we remember we have 24, but also you need to take into account the rinsing when you do the filtration, the neutralization later on. You need to consider the rinsing, especially after the acid demineralization. You need to rinse first before you continue with the hot water extraction. That's maybe 5 liters there, and then during the neutralization, at the end, after the thing is neutral, after the chitin is neutral, we need to rinse with the distilled water. So let's say we top up another 5 liters, so 24 liters during the extraction, and then let's say 5 during the rinsing. So 24 times 10, plus 10 liters is around 35 liters lah. So we have here around 40 liters of distilled water. So make sure you prepare this well in advance. Okay, and because acid doesn't work well with the with the stainless steel, so we need to have a bucket to do the hot water acid demineralization step. So we use this 20 liter bucket. Okay, this 20 liter bucket, and this bucket is basically made up from can you hold it? It's made up from the PP. Okay, so from the polypropylene. So polypropylene is good enough to resist acid, and also you need to make sure also your bucket is thick lah. So this is industrial bucket. It's made from the polypropylene, and it can contain the dilute acid. This is concentrated acid, but later on when you use 1 molar concentration, we will dilute it. So we will use dilute acid 1 molar, which is able to be this container able to contain that lah. Okay, we also have this the stainless steel pot here for alkali deprotonization later on. The reason why we don't use this plastic is because during alkali deprotonization we will use heat. We will heat our sample 80 to 65 degree. So you need something that can resist the heat lah. But plastic, then it's not good lah. For the acid demineralization, we only do it in the room temperature, so you don't need any metal or whatever. So this more than enough lah for room temperature extraction. But for alkali deprotonization, we need heat, so that's why we use this heat conductive material, stainless steel. The reason why we cannot use acid into this, cannot do the acid extraction into this, is because you will corrode this thing if you use acid at any concentration. For example, this is our previous our previous pot, stainless steel pot. We use it to dilute some acid, to work some acid in this thing. You can see there are the corrosion. You can see it's very clear, the corrosion happening lah. So that's the reason why we don't use acid. Acid and metal doesn't work well. Okay. Okay, regardless whether you have, this is 304 grade metal, which is a standard metal for kitchenware, so it doesn't handle acid. Acid will corrode this steel. Even you have 316 or 316L grade of stainless steel, also is not recommended to use acid lah. 1 molar acid will definitely corrode that stainless steel grade. Okay, and lastly, we need balance for measuring and so on. This is our setup in our film hood. We have overhead steerer here, and we also have the hot plate here. So the overhead steerer here, we use this Teflon pedal because it can resist corrosion from acid or alkali. So this is a pedal type steerer. It's allow the tangential mixing, which is good for a large volume of sample. Here we need to make sure when we find a bucket for acid demineralization, the bucket must able to be fit within this overhead steerer size lah. But for heating later on, we need to use this magnetic steerer. So if we put the magnetic steerer on top of this, then it already takes some height there. So we need to make sure our pot that is sort of like have enough height lah, in order to go below this steering ni lah, overhead steerer, because our max we already put there, the what called the boss head there, the clamp is already at the max, so we need to take into account all that thing in advance lah. So we already calculate that this thing, both of this thing can be put on top of this and still can be stirred properly lah. But for the acid demineralization, we don't need any heating, so this is more than enough. And also we have this timer to make our life easy. So that is basically all about our setup for extraction process. For filtration process after acid demineralization and hot water extraction, and also during neutralization after alkali depressurization, we will use this type of filtration setup. So here we have our what we call our big buncher funnel, and we make our own vacuum filtration system. So we use this what we call the pot, and also we make our O-ring to seal the what we call the top here. So this we just use the acrylic, and this is our buncher funnel, 250 mm in size lah, 250 mm in size, because we will filter a lot of sample. And we make sure also we ready with this spatula for us to what we call to stir the thing to increase the filtration rate lah. And this we need to make sure first, because before we use this, we need to make sure the vacuum is working. So in order to test the vacuum, we prepare our sort of like a container here so that it can fit our filter here upright, so that it doesn't flip when we put it. So we want to test this, whether this pump working or not. Okay, so we on the pump. So how we test manually is just we put our hand there. So if let's say there are some suction happen, then we can say that this is good enough for our filtration lah. Okay, so you can see that there are some suction happen because this pump doesn't have any gauge, so we need to do it manually lah. Okay, so we can put that on top again. And for filtration, we will use the filter close, so we can close the pump now. So we make sure we ready with the filter close. This filter close have the dimension of 65 or 70 by 70 centimeter. But the most important thing is that we must make sure this close can fit into this what we call the buncher funnel. And fit, we mean that it can fit until the depths of the buncher funnel and still left some part outside, because it makes us easy to take our sample later on. So make sure your what you call your filter close big enough to cover this and go to the depths. For the filter close itself, it can be any close, just doesn't really matter which close that you use. Okay, this basically work well. The setup work well for alkali or hot water extraction. But when you use what we call acid, after acid demineralization, you need to filter a little bit. You cannot use this. This is stainless steel. It will corrode the stainless steel. So we will use this what we call the bucket. This is industrial bucket, PP polypropylene bucket. So same the bucket that we use for our extraction before. So we buy 2 of this. So we just take this up, take everything up, and then we put on top of this. Okay, because this pump, okay, this pump also contains some metal inside, and even though there are no for 1 molar acid is very dilute, but then still when you use a pump like this, some vapor of the acid will go inside this hose and will corrode whatever metal inside this pump. So we don't use the pump, so we can take it out. We can take it out, and for acid part only, we just let it drain down or filtered naturally by gravity. So that's why we need to use some ladle lah. We need to have some ladle ready to to fasten the filtration. So that's the precaution you need to take care when you deal with the acid. Okay, and then we need to prepare our bucket there to take the tap water, because during the neutralization later on we will use a lot of tap water, and that's the tap water. And also sometime if this is quite heavy, we will bring this what we call cebok or whatever it, take it and then just put like that, so much easier lah. And also make sure you prepare also extra distilled water, because for rinsing purpose, okay, regardless if is it after the alkali extraction or after the acid demineralization, before we go further to the next step, we need to rinse it with the distilled water in order to remove all the dissolved mineral from the tap water. Okay, one of the reason why we mentioned that it's very important for you during the acid filtration that you use this plastic rather than the the metal, is because metal will corrode. Okay, so that is example of corrosion happen when you use metal. And also, as I said before, even though the pump doesn't have direct contact with the acid that going down, but the vapor of the acid can be sucked by this pump, and what will happen, it will corrode whatever metal here. Example of corrosion is this. Okay, so this is our old pump. So you can see what happened after we just use a very few time only, but you can see now the effect of acid vapor. It's not like at 1 molar concentration of HCl, there are no vapor at room temperature. But then when you suck using the vacuum suction, then that's cause the some of the acid vapor goes in lah. So that's the reason why you can see the corrosion. You can see now this here, and there is quite damaging lah. Okay, so this is what happened when you use acid to the metal. Okay, and lastly, before I forget, here you prepare also your container to contain your sample, and also it's good idea to have this spray. We put distilled water here. The reason here we use this is sometimes there are some splash on the side here of your sample, then we can spray it so that we can go down much easier lah. So this is good stuff lah. I mean, you can just. So basically that's it for what we call for filtration, our filtration setup, whether it's for after acid demineralization or after hot water extraction, or during the neutralization in the final step after alkali deproteinization. So this is what we use lah.